All right, welcome back, guys. This is Mr. Martin. We are on 11.2, solve using square roots. So, I know the last video is kind of long. I'm going to try and make this a little bit quicker as we go along. Our last section, though, we had a good chunk of properties to learn. That's what ate up most of our time. So we will be using that skill set of simplifying radicals in order to solve using square roots. So now we are jumping into equations. Let me use a little different color here. Equations, and we're going to be looking for both positive and negative solutions. So go ahead and get that objective written down. Pause the screen if you need to. Let's jump right into it. So we're going to need to recall what a quadratic equation looks like. And I've been shouting this from the rooftops for many moons. So you might have written it down already, but if you haven't, we got ax squared plus bx plus c. Remember, this is our standard form of a quadratic. We know it's a quadratic because of the squared exponent. So we might see, a couple of examples like 5x squared plus 6 equals 4. I hate writing 4s, man. This tablet is no bueno. Alright, so we got stuff like 5x squared plus 6 equals 4. And we might see something like, I don't know, x squared equals 10. Alright? So you might have all the terms. You might not. And you might need to reorder them. Okay. The other thing that we want to recall, what is the graph called of a quadratic function? We know it looks something like this, and it is called a parabola. For those of us who forgot, good thing to know. All right, so I gave you these 3 different graphs here because we know. Alright, imagine this parabola was here. We know that we have things that are called zeros. And these zeros, if we date back to our zero product rule, tells us how many solutions that a quadratic is going to have. Remember, our solutions are these zeros, also known as the x-intercepts. So you might have a quadratic that has one solution, okay? And that might be a quadratic that looks like this. Something that touches the x-axis only once at one point. You might have a quadratic that has 2 solutions. Something that looks like this, right? It's going to cross at 2 points. And you might even have, let's throw a sad graph in here, one of these. You might have a quadratic that does not get anywhere near the x-axis, so there are actually no zeros for this graph. So we're going to talk a little bit about these. And just purely for Algebra 1 purposes, these are going to be our no solutions. When you get into Algebra 2 and pre-calc and stuff like that, you're going to see something a little bit different for this. But for the most part, this is what we're going to be working with. Alright, make sure you got this drafted up. Pause the video, rewind if you got to. I'm going to move forward. Alright, so example number 1. We want to solve our quadratics using the square roots. And we know that, remember, the square root is the inverse of the squared property. So if I'm squaring something, the opposite is going to be the square root. And if we remember that property about even valued indexes and even valued exponents, remember that's where we dove into talking about the plus or minus. So we're going to need that. Ignore that little voice crack if you heard it. All right. So we want to get our variable term by itself, and obviously it's going to have an exponent because we're in the square rooting section. So this first example is pretty easy. We already have our variable by itself on one side, and then we have our non-variable term on the other side. So once you get down to this part, okay, this is the final stage before you can square root. We know that we have a squared exponent, so we want to do the inverse property, and we got to do a property of equality and do it to both sides. So I'm going to go ahead and do the inverse property and square root both sides. But like I said, anytime we square root, we always need this plus minus. So once I square root a quadratic term, remember there's always a 2 here if you don't see a number. This 2 matches this 2, so we can actually just get rid of the radical and we are left with just the x. If we square root of 16, 16 is a good whole number. We know that the square root of 16 is 4, right? 4 times 4 is equal to 16. We know that. So we got to use our plus minus. So we write plus minus, and then we have a 4 here. Now what this is telling me, this is actually telling me that I have two solutions. That I have x is equal to a positive 4, and I also have x is equal to a negative 4. So we always want to write our two solutions. We could leave it as x is equal to positive negative 4 plus or minus 4. We could write it like this: x is equal to 4 and x is equal to negative 4. Or if you want to date back even further to our previous lessons and use the solution set brackets, you can write them in as such. All right, let's try the next example. Is my variable term my quadratic term by itself? No, I have a coefficient of 2. So I use my equation solving skills that I remember so greatly and do the inverse property to both sides to get my variable term by itself. So I got 2 divided by 2, that's going to leave me with x squared. 100 divided by 2 gives me a 50. And then now I want to go ahead and square root both sides. So the square root of x squared gives me an x. And now I'm faced with something that I saw in the last section. Is there an actual perfect square of 50? No, there is not. So I need to figure out how to reduce this. We know that the square root of 50 is the same as the square root of 25 times the square root of 5. But don't forget, you are going to have a plus minus. So we can square root 25. So we are left with x is equal to plus or minus 5. And then we have the radical 5. So this can be my solution set. Or if you want to use this right here, we can have 5 radical 5 and negative 5 radical 5. I would kind of get familiar with this solution set style because on your homework, this is what your answer key is going to look like. So it's a good way for you to check your work. All right, I'm going to do one more with you. I'm going to let you guys handle the 3 at the bottom. All right, so this is a multi-step equation that we got to solve. We got this plus 5 right here. Remember, we want to leave our variable term last. We want to get rid of any kind of plus or minus terms. Move those over to the other side. So I can do that by subtracting 5 from both sides. That leaves me with 2x squared is equal to, what is that, 72? If my brain works correctly. Then I want to divide both sides by 2. Then I'm going to get x squared is equal to 36. Alright, now I can go ahead and let's try some other colors here. Now I can go ahead and square root both sides. Square root gives me x is equal to, once I do that square root, I better put that plus minus, and square root of 36 is just a good old whole number 6. So my solution is negative 6 and positive 6. Alright, very good. Go ahead and pause the video right here. Try a couple on your own and come back, see what you got. Alright, welcome back. So this first one, we subtracted 5 from both sides. We get 2x squared equals 0. Then we divided both sides by 2 and we got x squared equals 0. I went ahead and square rooted both sides. And then notice how I just put x equals 0. I I know I said don't forget the plus or minus, but do we really need a plus or minus for 0? No, we do not. So this is actually one of those examples where we have that one solution. All right, our next one here, we got minus 20 that we got to add to both sides. So we get 3x squared equals 120. Divide both sides by 3, we get x squared equals 40. I went ahead and square rooted both sides. Then I get a plus or minus radical 4 times radical 10, right? And then I square root that 4. It gives me a whole number of 2. I did not forget my plus or minus, so I ended up with x is equal to plus or minus 2 radical 10, with my following solutions down here as negative 2 rad 10 and 2 rad 10. All right. If you look right here, we subtracted the 10 from both sides. That actually gave us a negative 4, and I tried to go ahead and square root it, but then wait, hold the phone. Can we do that? No. Well, you can, but not so much really for what we're learning right now. For our unit specifically, okay, and if you have some space on your paper somewhere, I'm just going to write it here in purple. Our no solution, okay, is for when we square root a negative, okay? In our lesson here, we are not going to take the square root of a negative. What this actually does, I'm going to talk about a little bit, but you don't really need to know it. This is what gives us those imaginary numbers, okay? If you were to have to square root a negative number, the square root of a negative 1 equals what we call the letter I, and that stands for imaginary number. But we're not going to get into that, so if you ever find yourself square rooting a negative sign, just stop yourself, and we know we're going to have a no solution. So that's what I will be looking for from you, is that no solution right there. All right, very good. Let's go to our next example. These types are where we have an actual quantity squared. Remember, a quantity squared is something that has more than one term inside of our parenthesis, like we see here, x plus 1. And on the second example, we have the, the x minus 3. So we want to do the same thing. We want to follow the same rules. Here we have our quantity by itself on one side. There's no other terms next to it. So we can go ahead and just jump right in and square root both sides. So this whole quantity is what's being squared. So this index of 2 and this 2 are going to get removed, and I'm left with what's inside, and what's inside is a nice old x plus 1. Okay, we square root 16. 16 is a good number to square root. That gives us a 4, but we do not forget our plus or minus before we put our 4. So now here we actually have, again, two solutions because we got that plus or minus. So the way that I've taught this before, I've always called it case 1, case 2. But you kind of want to think of writing two new equations because you're going to have these two solutions. So what you have here is you have an x plus 1 is equal to a positive 4, and you also have an x plus 1 is equal to a negative 4. So me being as awesome as I am, I like to actually show my work so I don't make any mistakes. And I do this by writing out both equations. It only takes an extra little bit of time, but it might save you some heartache in the long run. So then now we just go back to solving an equation. I got x plus 1 equals 4. How do I solve this? I subtract 1 from both sides. So I get x is equal to positive 3. And then I subtract 1 from both sides on my second equation, and I get x is equal to negative 5. Okay, so I have my two solutions here. We can leave them like this. Remember, we can't write plus or minus because these are two different values. But we can use our solution set squigglies. And I'm going to put these in order from left to right, just like so. All right. Go ahead and pause the video. I'm going to let you try the next one and come back, see if we get the same thing. All right, welcome back. So what I did here, if you see this positive 7, we got to subtract 7 from both sides. 32 minus 7 gave me that 25. And I was left with the x minus 3 squared. So we square root both sides. We get x minus 3 equals plus or minus 5. And then we write our case 1, case 2, or your two new equations, or whatever you want to call it. I'm going to give you that freedom. You can do what you like. But either way, you got to get to this solution here, right? We add 3 to the positive 5. We get 8. We add 3 to the negative 5. We're going to get that negative 2 right here. All right, so I got one more example for you. They're actually similar examples. So you know what? I'll tell you what. I'll walk you through one more and then you do the last one. All right. Probably want to add 3 to both sides. Let's do that. So that's going to leave me with 5 times x plus 8 squared equals 20. Then I want to divide both sides by this 5. So that's going to give me x plus 8 quantity squared. Remember that terminology? And then I got this positive 4. I'm going to go ahead and square root this. And then we get rid of that exponent, so I'm left with x plus 8 equals, I got my plus or minus 2. And then I'm going to do it without drawing those arrows. I think we know where we're going by now. So I got x plus 8 equals positive 2, and I also have x plus 8 equals negative 2. I'm going to subtract the 8 from both sides. I'm going to do this one in my head. 2 minus 8 is going to give me a negative 6. Then I'm going to subtract the 8 from a negative 2, and that's going to give me a negative 10. And then I like drawing these squigglies just because they're fun. And boom, it's a wrap. Dunzo. Alright, pause the video here. You do this last one, see what you get. Okay, let's see what you got. You probably should have added the 6 to both sides. That'll get you the 4 times x plus 5 squared equals 32. We divide both sides by 4. We get x plus 5 squared equals square root of 8. Now we can't perfect square root, so that breaks us down to radical 4 times radical 2. And we have the x plus 5 on one side. Take it a step further, I get x plus 5 equals plus or minus 2 rad 2, okay? So now I split it up here, and this might look a little different to us. Some of us might have stopped here and went straight to unpausing. And I decided to leave it here and kind of walk you through this last step. Remember from our radical properties in the last section, right? In order to add or subtract the coefficients, you have to have the same radical with the same radicand and the same index and all that blah blah blah. To get this x by itself, we got to subtract a 5 from both sides. Okay? And I'm going to do this on both of these. So those would go away. I'd be left with the x. But now the question lies right here. Should I do negative 5 plus 2? Well, you got to ask yourself, does this negative 5 have a radical 2 next to it? And no, it does not. So you cannot combine these terms. They are not like terms. So you simply just have a negative 5 plus a 2 radical 2. And on the opposite side, you would have x is equal to a negative 5 minus 2 radical 2. And this is where that plus or minus comes from right here. So you can write your solution as negative 5 plus 2 radical 2 and negative 5 minus 2 radical 2. And to be fair, if you really wanted to, you could leave this as negative 5 plus or minus 2 radical 2. you might see this syntax somewhere along any type of additional resources you might be tapping into, because it is highly encouraged to look at other people's math, not just my own. All right, well, good job. I think you guys did fantastic. I feel it. I know it. You'll do great on the homework. Please use that class time wisely. Ask each other for help. Use each other as a resource. And have a great day. Peace.